Today we're going to talk about section 6.5 in your textbook, which is about solving absolute value equations. Before we get into solving these things, let's remind ourselves what absolute value is. We write absolute value of a number using the vertical line symbols. And the absolute value represents a distance. And what sort of distance depends on the context, but for us, this is going to be distance on a number line. If we have an equation, this distance has a kind of a cool interpretation. Let me back up just a moment before I get too far in. So the absolute value of this distance, the -7, this has maybe a little better interpretation if we write it, this in maybe a more formal way. Maybe if we do a distance between something separated by subtraction. So our interpretation of this would be the distance between -7 and 0. And the distance between those two numbers on a number line, if you drew a number line with -7 somewhere over here, 5, 4, 3, 2, 1, 0, will be count the spaces. So 1, 2, 3, 4, 5, 6. These things have a distance apart of 7. The positive number 7, where distances are always positive. Okay, so in this interpretation of absolute value, we're thinking back to distances between two objects. And that should make a lot of sense, because -7 minus 0 is -7. The absolute value of -7, therefore, is the distance between -7 and 0. In the same vein, this absolute value expression is interpreted as the distance between 5 and 2. And how far apart are 5 and 2? They seem to be 1, 2, 3 spaces away from each other. So with that in mind, the goal of this lesson is to be able to apply absolute value to equations and see what happens. So there's a warm-up reserved for you to do on your own, and we'll address this box in just a moment as a shortcut. So when we're first initially addressing how to solve equations, let's try to rewrite rewrite an equation as something minus something else. So if there's nothing to subtract, then we're presented with a 0. And we can interpret this as some number minus 0, or the distance between some unknown number and 0 is 9. So one way to approach this might be to draw a number line, put our 0 in the middle, and say what number is 9 places away from 0. So I could walk 9 spots to the right away from 0, and I should end up at 9. Or I could walk 9 spots to the left on the number line. I end up at -9. So by this distance approach, the solutions to this equation should be x is either 9 or x is -9. Similarly, we could interpret the second one as the distance between some number and 7 is 9. So in a similar fashion, we could draw a number line, put 7 as our center, and figure out what numbers are 9 units away from 7. It appears 16 should be 9 units away to the right. or negative 2 is 9 units to the left. So our solution should be x equals negative 2 or x equals 16. We can also interpret maybe with a plus. Notice that in the first two interpretations, and up to this point, we've had subtraction in the middle. Subtraction is a distance, is a way to measure how far things are apart. So maybe if we want to use this graphical approach, one way might be to rewrite this as x. This could be thought of as x minus negative 4. Or what numbers are 3 units away from negative 4? Could be one way to approach this problem. An alternate method would be to try to find an algebra shortcut, which is what the intent of the box above is. So notice that the box above said if you have an equation set up with an absolute value, you can, as long as the distance is bigger than or equal to 0, we can rewrite this as what's inside is equal to the positive distance, i.e. walking to the right, or what's inside is equal to the minus distance, i.e. walking to the right. Excuse me, walking to the left. So maybe rather than continue to use number line, maybe I try this approach. So I say, oh, I have an absolute value equal to some positive number. So that means I could take the stuff that's on the inside, and I'm trying to walk to the right on the number line, or I take the stuff on the inside and I walk to the left on the number line. Once I'm here, I think of these as two separate equations, and I solve each separately. So these are one-step equations. I subtract 4 and get x equals negative 1. There's 1. Or I subtract 4 and get x is negative 3 minus 4 is negative 7. Maybe we make sure that this matches our graphing approach. So if I took my rewritten equation with a subtraction, this should come out to be the same numbers that are 3 units away from negative 4. And 3 units away from negative 4 to the right is negative 1. And 3 units to the left of negative 4 is, in fact, negative 7. Our graphing approach matches the algebra approach. For a lot of equations, this algebra approach can be a little bit faster. So especially when they get a little bit slightly more complicated. Like for example, now I have things outside of the absolute value. So my approach is to get the absolute value by itself, isolated, and then use the number line approach or split it into two equations. So for example, I'm going to get rid of the negative 4.1 minus the 4.1. You get 2 times the absolute value of s is 14.8. I want to get rid of this, multiply by 2, and get absolute value of s is 7.4. From here, I could use the graphing approach. Maybe I notice that I just say what's the absolute value of s, or what numbers are 7.4 units away from 0. Well, I think that's very clearly either 7.4 or negative 7.4. Similarly, how about I add 5? It's equal to 24. Divide by 4. And you get t plus 9 is equal to 6. I try the algebra approach and I say, well, I take what's inside, is that equal to walking to the right? Or take what's inside, is that equal to walking to the left? And voila, my two answers. This even works when what's inside gets even more complicated, like there's like a number multiplied in front. It's still going to boil down to get the absolute value by itself, Divide by 3, you get 4x plus 2 is equal to 6. And now, since I have something inside the absolute value, I write two equations. I take what's inside and walk to the right, or take what's inside and walk to the left, and solve each. Minus 2, minus 2. Minus 2. And voila, my two answers. On the back side, there's some more examples of times when maybe absolute value is not possible to be solved. So how do I decide what's going on, if it's even possible to solve? Well, I still approach the problem in the same manner. Subtract 3 from both sides. Divide by 3 and get 2x minus 8 is equal to negative 1/3. There's a major issue here in that now I have an absolute value that's equal to a negative number. So this is saying this says that the distance these two numbers is a negative. And distances are never negative. Distances are always positive. Which is not possible. Therefore, no solution. Maybe I try to trick you and put a negative. I start with some negatives. Well, just because it starts with negatives doesn't necessarily mean I'll get negatives when the absolute value is all said and done. So I have to get the absolute value by itself before I make a decision. So I add 7 to both sides. You get minus 3 times the absolute value of n plus 2 is equal to negative 3. Divide by negative 3. You get the absolute value of n plus 2 is equal to positive 1. This says the distance between n and negative 2, or just between these two numbers, happens to be 1. That's good. Since the distance is positive, you can finish solving this. So I take what's inside, set equal to walking to the right, or take what's inside and set equal to walking to the left, and solve. Maybe like the first one, it looked inconspicuous. Maybe this doesn't look that bad. I get the absolute value by itself. Divide by 2. Again, this says a distance cannot be negative. So it's not possible to solve. Again, I have an absolute value, so this is a distance on the left. It should be a distance on the right, but distances are not allowed to be negative. Not possible. The final piece to absolute value equations is a special kind of absolute value equation called an absolute deviation, where absolute deviation is generally in the sciences talked about as the error in a measurement. Or quantity. In general terms, I could say the absolute value, the absolute deviation of two numbers of, in this case, x from 7.6 is equal to some value. So if I just use the formula listed, I should have an absolute value of something. It's equal to the absolute deviation. In this case, the absolute deviation is 5.2. Of what two numbers? Of x and 7.6. Once I have my problem set up, I can find those values of x by solving like we did for all the other ones. I could be more than, x could be more than 7, the distance could be to the right, or maybe this value of x is to the left. What is this, 2.4? Again, in the measurement quantity field, our final example is a really good representation of that. So the volleyball league is printing a 2-minute radio ad to announce tryouts. That has an absolute deviation, or has an allowable error of 0.05 minutes. Find the minimum and maximum times this could be, or what are the values? So if I let x be the length of the ad, then I'm trying to find, I know that the ad has an absolute deviation of 0.5 minutes. So I know I have something that's going to be subtracted, and its absolute deviation is 0.05. In between what? The length of the ad and the 2 minutes that it's allowed. So the absolute deviation between the length of the ad and the 2 minutes is allowed could be written like this. So to find max and minimum, I set up my two equations, what's inside, either positive or negative, and solve, and find that x could be either 2.05 minutes or x could be 1.95 minutes, with the biggest one being the maximum and the smallest one being the minimum.